We are back. This subtopic is about the mole concept. First, what is a mole? In the beginning, students have difficulty understanding the concept of the mole, but think about it like this. How many eggs are in a dozen? 12, right? Similar to this, because everything around us is made up of many small particles, scientists decided to group a bunch of particles together and give it a name, the mole. So 1 mole is equal to 6.02 times 10 to the power of 23 particles. And particles include molecules, atoms, and ions. So what is the precise definition of the mole? The mole is a fixed number of particles, and it refers to the amount of a substance. We can use terms such as mass and molar mass to also express the term mole. Mass over molar mass can actually be used to derive the mole. But what is a molar mass? The mass of 1 mole of any substance is known as the molar mass. As you can see in the units right here, it is the mass in grams of 1 mole of any substance. This is a real IB question about the mole concept, and this type of question is frequently tested. Let's first look at the question. One amount of oxygen in moles contains 1.8 times 10 to the power of 22 molecules. So we're trying to express molecules into moles. The particle in interest is oxygen, which is a molecule. So 1.8 times 10 to the power of 22 molecules of oxygen needs to be expressed in moles. So we can transfer this to moles by multiplying this value. Because we know that 1 mole contains 6.02 times 10 to the power of 23 molecules. This will eliminate molecules and leave us with moles. 1.8 times 10 to the power of 22 over 6.02 times 10 to the power of 23 moles will be our answer. This can be easily calculated, so this will give us 0.3, and this will give us 0.1, leaving us with 0.03, which is B. Okay, now let's read the question. Which sample has the least number of atoms? These are 2 keywords of this question. The particle in interest here is now atoms. However, all our answers are given as molecules, so we need to change them into atoms. First, how many atoms make up a sulfuric acid? 2 hydrogens, 1 sulfur atom, and 4 oxygen atom makes up 1 sulfuric acid molecule, so 7 atoms. How about this molecule? 8, 4, and 4. Now, I'll write down the conversion. So 1 mole of H2SO4 can be written as 1 mole gives us 6.02 times 10 to the power of 23 molecules. Why is it molecules up there? Because H2SO4 is a molecule, right? But we want to know how many atoms there are. So we know that in 1 molecule of H2SO4, we note that there are 7 atoms of we know that there are 7 atoms. So this will eliminate moles, eliminate molecules, and we'll be left with 6.02 times 10 to the power of 23 times 7 atoms. Okay? I'm going to write this big value as alpha, as short. Now let's look at B. 1 mole of CH3COOH gives us alpha over 1 mole times 8 atoms over 1 molecule. So this will be 8 alpha atoms. A was 7 alpha atoms. How about C? In C, there are 2 moles of H2O2. And alpha over 1 and 4 atoms over 1 will be multiplied. This will give us, again, 8 alpha atoms. Similar to C, D also has 2 moles of ammonia times alpha over 1 times 4 atoms over 1, leaving us with 8 alpha atoms. So looking back at the question asks us to find the least number of atoms. That will be A, because it has 7 alpha atoms, which is the smallest number out of the 4 different answers. So our answer is A. Now, we're going to learn new concepts and terms. As I mentioned before in the previous videos, you need to know how to define the terms that are highlighted in yellow. You don't have to be exact, but you need to have the key words or phrases in your definition. First, isotopes are atoms of the same element with the same number of protons but different number of neutrons. You might have learned this in your previous courses, but an atom or ion has an atomic number. An atomic number is the number of protons, and a mass number. The mass number represents the number of protons and neutrons. So these two numbers show how many protons, neutrons, or even electrons make up the certain atom or ion. Here in the example, the number next to chlorine is its mass number. And again, it represents the number of protons and neutrons. However, the number of protons is fixed as 17 because there are both atoms of the same element. So we can derive the number of neutrons for each atom. For chlorine 35, there will be 18 neutrons, and for chlorine 37, there will be 20 neutrons. So, looking at this, we can see that there are atoms of the same element with the same number of protons, but different number of neutrons. So we call this isotope. Next, relative atomic mass. The relative atomic mass of an element is the weighted mean of all the naturally occurring isotopes of the element relative to carbon-12. So, as we mentioned in the previous example, like chlorine 35 and 37, there are many naturally occurring isotopes. When averaging the values of all the isotopes, we can figure out the relative atomic mass for each atom. This is the number that appears on your periodic table, and it will be further explained in topic 2. Next, relative molecular or formular mass. For molecules, the term relative molecular mass is used. For ionic compounds, the term relative formula mass is used. These two words both point to the same term, molar mass. Next, empirical formula. The empirical formula shows the simplest whole number ratio of the atoms of each element and a particle of the substance. So looking at the example, we can simplify this glucose molecule as CH2O, which is in its simplest whole number ratio of atoms. On the other hand, the molecular formula shows the actual number of atoms of each element in a molecule of the substance. So an example would be glucose, as it shows the actual ratio of atoms that exist. This question is about empirical formulas, and let's take a look. The percentage by mass of the element in a compound is 72% of carbon, 12% of hydrogen, and 16% of oxygen. What is the mole ratio of carbon to hydrogen in an empirical formula of this compound? So, since they gave us the percentage by mass, we can actually change this into grams. Because they are in grams, if we want to find the ratio, the mole ratios between these atoms, we need to change them into moles. So we can do that by dividing 12, because we know that mass over molar mass is the number of moles. This will give us 6 moles of carbon. How about hydrogen? 12 grams. We divided it by the molar mass, which is 1 gram per mole. We can find its mole, number of moles. How about oxygen? 16 grams. 16 grams per mole. Get 1 mole. So the ratio of C to H to O will be 6 to 12 to 1. So if we write this down, it will be C6H12O1. However, the question asks us to find the mole ratio of C to H in the empirical formula. So it will be 1 to 2, and the answer will be B. Another question. I want you to stop the video and try it on your own. Since this question is not a multiple choice question, you can use your calculators. The questions we looked at previously were all multiple choice questions from your paper 1. So you weren't allowed to use your calculators. Now you can. Okay, let's read the question. The relative molecular mass of aluminum chloride is 267. And its composition by mass is 20.3% aluminum and 79.7% chlorine. So if I clear this out, I can express this as shown. I want to determine the empirical formula and the molecular formula of aluminum chloride. First, I need to change them into moles in order to find the simplest whole number ratio between the two atoms. So the molar mass of aluminum is 26.982 grams per mole. So I need to divide it by the molar mass. And I will get 0.75235 moles. And for chlorine, the molar mass is 35.45 grams per mole. So if I divided it, then I will get 2.2482. So these are the two mole values. But they are very difficult to compare, right? So what I can do is I can divide each number by the smaller number of the two. So in this case, it's 0.75235. 0.75235. Then this will be 1. And if you plug this into your calculator, it would be approximately 3. So now I can compare these two atoms. So Al1Cl3. That will be our empirical formula. But how about our molecular formula? The molecular mass of this empirical formula is plus 3 times, which is about 133 grams. However, our relative molecular mass of aluminum chloride is 267, which is about twice the amount of the empirical formula. So we can actually assume that our molecular formula will be twice the empirical formula. So Al2Cl6. That will be our molecular formula. So this is our answer. That's it for this video. I'll see you in the next one.